Hello everyone. Today I am going to explain you our approach to the problem statement ID SIH1579, which is titled Developing Writing Pen and Writing Pad for Children with Specific Learning Disabilities. So we are from team ElectroGems and we are providing an innovative solution for this problem statement. So before delving into the solution, let me explain you further about the problem statement. So the problem statement description is the main context is today CBSE board is providing an option known as Scribe to the people with specific learning disabilities. Scribe is a person who will assist the candidate in either the reading of question paper or writing the answer for the candidate. The malpractice which is going on today is people are training scribes instead of actual candidate, which is leading to additional boost up to the candidates with specific learning disabilities in academic perspective. So our proposed solution is we are giving two devices, which is a scribe, that is writing pad, and a reader, which is reading pen. So the writing pad, what it does is it will take the voice input from the candidate and convert it into text and store it in the SD card module. What the reading pen does is it will capture the image of the question paper, convert it into text, and provide the speech output which can be heard by the candidate. Coming to the additional support, if there is no Wi-Fi in the area, we will be providing an additional ESP32 module which will act as an access point to be a communication barrier between communication bridge between the local server and the end device, which is either the writing pen or the writing pad. So before moving any further, let me explain you our technology stack. So the programming language we are using is embedded C++ for programming the microcontrollers and Python for developing models and software for the optical character recognition as well as speech recognition. The technologies used are OCR, which is optical character recognition, and laser guidelines we are providing for the user in order to align the question paper for more sharper and accurate outcomes. For voice to text, we are adapting Google API in the presence of internet or the VOSK model in the absence of internet. So for text to speech, we are trying to implement phonetic mapping on the TMS320 DSP processor or the MIG2 DSP processor. Hardware we are using is ESP32, mic, SD card module, and a DSP processor either of MIG2 or TMS320, along with a 2.4-inch TFT display and a portable thermal printer, and also a ESP32 CAM module. So let me explain a process flow for the writing pad. First, the system starts and check for the display if it is full. If the display is full, it will ask the user if the text which is displayed on the display is right. If the user responds with yes, it will save to the SD card, or else it will handle the mistake which is asking the user to repeat the text again and then storing it in the SD card. If the user is if the display is not full, then what it does is whatever the speech that it received, it will convert it into text either from the Google API or from the local server implementing VOSK model. So if the received text, converted text, if it is a command, then it will execute the command. If it is not the command, it will write onto the display and again start checking if the display is the full. Now coming to what is executing command, we have chosen three terms as a command, so which is stop, print, and erase. If the user utters a word erase, we will erase the display, and if the user wants to print it, we'll print the information in the SD card using a thermal printer, and if the user wants to halt the process, he or she can utter a word stop in order to halt the process. Coming to the process flow of reading pen. In the process flow of reading pen, what we do is we start, once the system is started, it will check for the interrupt. So we are using play and pause as two interrupts. If the user clicks the interrupt pause, the system will be in the stop position until the interrupt play is received. So once the interrupt play is received, it will check if the question paper is available in the SD card module in the .txt format. If the question paper is already available in the SD card in the .txt format, then it will directly convert it into speech. If it is not available, then it will extract text from the image using optical character recognition, either from the local server, and it will generate a .txt output. The .txt output is stored in the SD card and then it will be converted into speech using either MIG2 or TMS320 processor. So coming to the feasibility and challenges, our idea is very feasible because the technology we are using is well established. So the chances of failing is very less, and all the hardware setup is readily available because we are not using any customized hardware. Integration is very easy as these are basic microcontrollers and peripherals which can be used easily. It is a cost effective. Our bill of materials came down to be 7,300 for writing pad and 3,200 for reading pen. This is for a prototype version. If we go for a production scenario, this can be reduced even further. And while coming to this solution, we have observed few challenges and also planned few strategies to mitigate them in the future. The major challenges we have observed is symbol recognition. If we take the scenario of subjects like chemistry and maths, these contain some symbols like integral symbol or a symbol of differentiation or a symbol of fraction. So these are some symbols which cannot be interpreted by the optical character recognition algorithm. And also in chemistry, if we observe, there are some chemical equations which also cannot be interpreted by optical character recognition accurately. So apart from this, we also have diagrams and tables which will hinder the optical character recognition algorithm. These are for the reading pen model. Coming to the writing pad model, the major challenges we have for writing pad model is the cloud latency. Cloud latency is nothing but the time taken to get the speech converted into text. This will take time because we have to transmit the data to the cloud, and once the cloud receives the data, it has to apply some algorithms to convert it into text and then retransmit back. So this will take a time, and the cumulative effect of this will be adding up to the candidate's examination time. So and also the major thing is multiple languages. If we consider an exam of Hindi or exam of Telugu, it will also have some instructions in English as well. So having a optical character recognition algorithm for bilingual question paper is a little bit difficult, but it can be handled using some pre-processing strategies. So the strategies we have planned in future to mitigate them are specialized models. So to convert mathematical terms and science equations into respective text representations, we have some models like for maths we have MathTalk and for chemistry we have ChemLib. So these type of models we can use in order to interpret text into symbols. And coming to local server, by running some models on the local server instead of sending the data to the cloud, we can reduce the latency a little bit. And model enhancement, we can enhance the speech to text recognition models further for more accurate results, so the chance of misinterpretation goes down. And in image processing and pre-processing, what we are trying to do is we are trying to remove additional tables and diagrams that are present in the image which will hinder the optical character recognition algorithm, and then replace them back. If the user intends to extract text from them as well, we will plan some additional steps to be taken in the future to provide these features to the user as well. So the major impact of our project is independence. We are providing children academic independence. We are giving a chance for children with specific learning disabilities to not to rely on anyone for their academic excellence. Instead, they can use this device to proceed further. And cumulative cost reduction, this is one time investment and can be used anytime forever by the student. This will make learning more accessible to the people with specific learning disabilities. This will reduce fraud because scribes can be mitigated, and also it lowers cognitive load by letting students to only focus on academics rather than struggling with their disabilities. And it is very user friendly. This can be used by children or people of any age group. It will encourage independence among children, and it will reduce the reliance on scribes. This will boost their academic skills, and this will provide a better future for people with specific learning disabilities. These are some of the references and research that we have done to arrive at this solution. One of them is design of self-writing smart pen using OCR technology. This is a project developed by in some engineering college. So we have taken some of the aspects of the project that can be integrated into our solution. MathTalk, which it is a library, as I mentioned earlier, which will interpret text into mathematical symbols. So VOSK is a speech to text detection model which is readily available, which can be integrated into our Python codes. This has models of various accuracies. We can choose between model of highest accuracy or with a model with medium accuracy with faster speeds. And uh, design and implementation of text to speech conversion visually impaired. This project has helped us in identifying some key aspects of text to speech conversion algorithm. uh, yeah, so this is all about our solution. Thank you for watching.